Hello there, my name's Chris Drummond and I work as an applied researcher at the NSW Water Research Lab in Sydney, Australia. Today I'll be presenting about some of the innovative uses of remote sensing that we've used, incorporating drones, smart cameras and satellites to understand some really complicated coastal lagoons and coastal estuary systems. And to do that, I'll be focusing on an area located 100 kilometres north of Sydney, called the New South Wales Central Coast. The New South Wales Central Coast has quite a number of intermittently open and closed lagoon systems. As you can see, one of them here at Avoca Beach. And my presentation will be split into two parts. The second part will be talking about a smart camera system that we've used to monitor intermittently open and closed systems for this particular council. And the first part will focus on the entrance to a large estuary here that looks like this, which is at Ocean Yamana Beach. So let's start with the Ocean Yamana Beach system. So this site is the entrance to a very large estuary, and it's at the interface between a constant battle between coastal forces and estuarine forces. And those two forces have been in a state of flux for a number of years, which have led to a history of unpredictable cycles of erosion, which has caused quite a bit of a headache for the local council that has to manage the area. The other issue is that there's quite a number of diverse stakeholders that have a vested interest into this site, as you'll see shortly. So here's a zoom in of the site here. And the first part that I'll talk about is the history of erosion along this foreshore road here that has been undermined in recent years. In as recent as 2015, this road was at imminent collapse into the ocean. The second issue is the navigation channel that runs past the ebb tide shoal supports a ferry service that is integral in connecting this area to Sydney. And this ferry service actually had to close in recent years because the navigation channel was silted up so much that it was too shallow for the ferry to operate. And the third diverse stakeholder is the ebb tide shoal forms one of the most iconic surf breaks in New South Wales. On its day, riders can get a wave that lasts for up to 6 or 7 minutes with rides up to 600 meters. And the local surfers here come from far and wide, and they really want to make sure that if there's any human intervention into this system, that the surf break is not detrimentally impacted by anything that you might do. Simple things like dredging the channel, they were very nervous about if it caused a loss of surfing amenity. So the question remains, how do you understand such a complicated site is problem number one. And the second one is, how do you manage it? So our approach was to throw every remote sensing tool that we had at our disposal at the site to understand it. So we built an understanding of the site from data, and we combined jet skis and drones to do the first digital twin of the site. We also used satellite-based monitoring of shorelines, and we paired that also with some smart camera monitoring. But the first thing we did was we went out and collected every single aerial image we could find of the site to generate one of these hyperlapse videos. And I can tell you, I've watched this video 1,000 times just to try and figure out which way sand is moving. So we compiled historical aerials dating back to 1940. We then pulled in satellite images from the late 1980s, near map high resolution aerial imagery from 2015, and then we threw in some drone surveys in more recent years. One of the things we noticed from that hyperlapse video was what we called a shoal blowout. So in early 2012, as you can see where that red arrow is, the shoal suddenly had a new channel forced through the center of it. So let's look at shoreline variability along the beach. So the COSAT tool was developed by WRL PhD student Killian Voss, and it is a tool that's open source and free for anyone to use. And what it does is it extracts shoreline data and tidally corrects it, from publicly available satellite imagery. And essentially what that means is that anywhere in the world, you're able to get 30 years of shoreline data. And that has really been a game changer in a lot of the projects that I work on, where you generally get coastal data that's maybe 5 to 10 years apart, and it's really difficult to understand what's going on. So we applied this to the Ocean Beach site to understand variability in the shoreline position. So here's a plot here of shoreline change at the beach in adjacent to the ebb tide shoal. And just to simplify things, I'm going to plot these generalized plots through each of those 3 transect locations. And what you can notice is these episodes of decadal oscillations in shoreline position. You can see in the late 1980s, it transitioned from a generally narrow period to a very wide period in the early 1990s. And this is something that we've seen up and down the New South Wales coast. It then went back into a cycle of narrow and wide again beach width. And this decadal oscillation, we could loosely correlate with subtle changes in wave direction and energy related to El Nino and La Nina oscillations. But what we noticed at this site was in 2012, that decadal oscillation broke down. And that coincided with a recession that lasted for up to 7 years. And lo and behold, that was exactly when we had that shoal blowout event, which obviously disrupted sediment feed of sand from the shoal onto the beach system. So let's look at some shoal variability. So we digitized some large sand waves or bed forms that were moving across the ebb tide shoal. And one thing that we noticed was there was a general pattern or a pathway for sand to be transiting towards the southeast here, towards the navigation channel. And from digitizing the crest of that sand wave, we were able to pull out rates, yearly average rates that sediment was moving. And what we found was shortly after the shoal blowout event in 2012, that rate doubled and tripled in the rate at which sand was moving in that direction. And we found that led to the issue where the ferry service had to cease to operate because of sedimentation of the navigation channel. So pulling it all together, what were some of the processes that were disrupted by this shoal blowout event? The first thing was it led to erosion along the beach, which culminated in the road becoming undermined and almost falling into the ocean. We also found that there was an increased rate of channel siltation, which led to the ferry service having to cease. And the third thing that occurred was it reduced the quality of the surf break, which the surfers really didn't like, because instead of being one long wave all the way from out the back to the shore, it essentially broke it into 2 waves. And so what we found was this shoal blowout event was something that nobody wanted, and it's something that we used, we were able to use to unite some quite diverse thinking around the site and how it needed to be managed. We found the common ground that we all agreed that we needed to avoid this shoal blowout event. Now on to the second part of my presentation, focusing on the use of smart cameras to understand coastal lagoon entrances. So at the UNSW Water Research Lab, we've been using cameras to monitor coastal areas for over 20 years, but these systems tended to be quite expensive and cumbersome to set up. So in the last couple of years, I've been developing a low-cost system that's powered by cameras that are as low as $700. And these cameras are solar powered, so they operate continuously. And they also have a SIM card in them that allow them to transfer data via cellular networks. So these cameras are capable of transmitting an image and a 10-second video grab every 15 minutes. And because they're self-contained, they're really easy to install. The most powerful thing with these cameras is the portal that I've paired them with. So as you can see here is a network of 9 cameras on the Central Coast that the local council use to monitor all of their ICOL entrances or their coastal lagoon entrances. So this particular council have to frequently go out and mechanically open these entrances because you have the issue of nuisance flooding and residents that have built houses along the foreshores of these lagoons. So they're constantly asking for the council to open the lagoons in the lead up to rainfall events to prevent flooding and also to improve water quality. So what we can see here is some of the ability of the portal to show the council the most up-to-date information, live feeds from the videos, but also on the right-hand side there, we've linked it to some forecast data and also measured water level data. So here's an example of Terrigal Lagoon where you can see the council went and mechanically opened it. And one thing that I find really interesting with these time-lapse videos is just how complicated the entrances can be. Once you go ahead and you open the entrance, it kind of has its own life, and you can see it migrated to the north here. But also what you can see is on any given high tide and low tide, the entrance was open to the ocean and then not open. And this is the kind of thing that's sometimes very difficult to understand when you're looking at water level data. It's hard to know whether the entrance is opened or closed. The other thing we're able to do is to pull out shoreline data from these cameras. So here's an example where you can see how the beach has retreated up to 26 meters in response to a large coastal storm event, and also how the lagoon entrance has changed throughout a 12-month period. The other thing you can do is you can use these animations to communicate to the general public. They don't always understand sometimes about ocean water levels propagating into a lagoon entrance, which can sometimes cause more flooding. And these time-lapse images are really a very useful way to communicate these complicated management strategies around coastal lagoon entrances. So here's an example at Avoca where you can see precipitation and then the mechanical breakout of the lagoon and the sudden drop in water levels, but then the ocean coming into the system. The other thing we've caught with the camera systems is a little bit of naughty behavior from the community. Here you can see a time-lapse image of unauthorized activity where the community actually got down with shovels and dug the thing out. And we were able to capture this in real time with our monitoring system, and the council could see immediately that they needed to get down there and monitor the situation. So just in summary, there's a number of remote sensing tools that are available now to manage coastal entrances, and these tools can provide new insights about coastal change in some really complicated locations. And the last point is smart cameras can be really invaluable in managing these coastal lagoons by having eyes on the ground. Thank you.